genome is, it didn't start over fresh. It is a result evolutionarily of 1.5 billion years of evolutionary change. So it's been decaying since day one. And yet the data is suggesting you couldn't even make 300 generations. How are you going to make 1.5 billion years? One of the explanations that evolutionists, they try to give several. They're mostly hand waves, but they try to give several. One of the explanations they give is what's called a hard selection, where they really come in very hard and say, okay, maybe Chimera was actually being too conservative. And let's say the selection is able to really come in much more aggressively and weed out much more of the mutations that are occurring in the organism. But even then, you still have some 100, maybe not quite, but remember it's 100 to 300. So we still have some 100 plus or minus mutations that are still left in the human, in that next generation, even with an aggressive removal of mutations. Okay? And the next generation, we're aggressive again, but what? We still have another 100. So we're still accumulating mutations. Even as we're taking them out, we're still not able to take out the vast bulk of them because we still have a huge amount right in here. So it still continues to build, even under that aggressive selection where you're trying to weed out a higher proportion of the mutations. You still continue to build mutation upon mutation, generation after generation. So you may slow down the decay, but this certainly is not a way to stop it, and it certainly is not going to explain how the genome could be 1.5 billion years old. Can't even be 300 generations old by this data. As I say, creationists aren't saying that we're that young either. But what we're seeing is based upon the information we know today, the genome is decaying very quickly. Okay, let's see what some of the evolutionists say. Higgins and Lynch, in their 2001 paper, they talk about what they consider semi-realistic parameters. When they say semi-realistic, what they're saying is anything that could be considered realistic, we're extinct in 2,000 generations. You have to get to what they admit is non-realistic mechanisms, non-realistic events occurring to prevent us from being extinct in 2,000 generations. That's their own admission. That's not a creationist. Higgins and Lynch are well-known evolutionary population geneticists, and they're admitting the best we can do is we can stretch humans out 2,000 generations. That's the best we can do. Okay? Looking at the mitochondrial DNA, which we haven't talked about yet, but the mitochondrial DNA is also degrading. A surprisingly large range of biologically realistic parameter combinations should have led to extinction of the evolutionary line leading to humans within 20 million years. Again, that's not creationists speaking. Now, evolutionists have an answer, or they thought they had an answer. Okay? Their answer was junk. And I don't mean that their answer was junk. Well, it was junk, but their answer was junk DNA. That was their answer. That's one of the reasons junk DNA was so important to them. Because think about it. If 98% of the genome was full of junk, that means 98% of these mutations are just going into regions that doesn't make any difference. So who cares? So you really don't have the mutation load building up that you thought you had because it's all going into areas that doesn't make any difference anyway. The loss of junk DNA is a double major blow to evolutionists because now not only is it what they didn't predict, and they've lost that where they thought, oh, all this junk, that just shows we're evolved and it can't be by a creator. But now we don't have any place to put the mutations. We're running out of cubby holes to stick mutations that aren't going to kill us because we don't have the junk anymore. Everything is vital. So it's a double whammy to them. So now all of a sudden they're facing once again the human genome is decaying. It's eroding away, and not only can we not stop it, we can't explain how it even got to where it is today. Because remember, mutations are supposedly what got us to where we are today, and yet mutations are what's degrading it. Isn't that interesting? So we use the very mechanism that's degrading it to claim that's the mechanism that built it to begin with. And that's called science by evolutionists. I don't call it science. I call it poppycock. Okay, beneficial human mutations. I'm going to talk about just a couple very quickly. You've heard about malaria resistance, where sickle cell anemia, the deforming of the hemoglobin causes the red blood cell to deform, so the protozoa that causes malaria cannot readily infect the red blood cell, and therefore you don't get malaria. So the idea is, okay, you know, do you die of malaria when you're 8 or sickle cell anemia when you're 15? I can do one better for the evolutionists. Instead of that, just forget about sickle cell anemia or even sickle cell trait. Forget about both of those. Let's go with the Duffy antigen. Okay, the Duffy antigen appears to be the apparent site on the red blood cell where the protozoa attaches. So what that means is that protozoa attaches on the Duffy antigen, infects your red blood cell, you get malaria. But in people that don't have the Duffy antigen, the protozoa doesn't attach very well. So they have a 50% increased resistance to malaria. But as far as I know, there's no physiological side effect to not having this particular Duffy antigen, which is a peptide. It's a small protein. As far as I know, there's no physiological detriment, unlike sickle cell anemia and even sickle cell trait, which do have physiological side effects. This, as far as I know, you're totally healthy. So we say, wow, here is a situation where clearly it would be beneficial to the humans, at least those in areas where malaria is, to be what's called Duffy null, that is not having the Duffy protein. You're much more resistant. You're still perfectly healthy. Wow, you've evolved. And that would be the reasoning evolutionists would use. It's beneficial, right? I mean, this clearly seems beneficial to me if you don't want to get malaria.